Okay, I just wanted to do a quick geometry review. A lot of students come to me and they have forgotten over some time what the perimeter of a rectangle is and the area, and what the perimeter of a triangle and the area of a triangle are. So I just want to talk about those for a second. First up, a rectangle. Um, Actually, before that, we have a one-dimensional, 1D, 2D, and 3D spaces that we deal with in the real world. Um, One-dimensional is just straight up length. Two-dimensional, we say is it's measured in square units, and three-dimensional we measured in cubic units. Okay, so length you can think of as a string, right? So if I were to wrap a string, well, first I could measure this, and that's what a ruler is good for, is measuring one-dimensional things. So in one dimension, this is approximately 4 centimeters, and if I measure this, it's approximately 2.5 or something like that. And then this would also be approximately 4, and this would approximately be 2.5. So those are one-dimensional lengths of sides. So we can think of as how much string, if I took string and I wrapped it around a rectangle, how much would go around that shape? And that would be called the perimeter. So the perimeter of actually any shape, so rectangle, triangle, hexagon, anything is just you add up the sides. So A plus B plus C plus dot dot dot. As many sides as you have, you just add them up. And rectangle takes a special idea because two sides are the same. So you could say, well, 2 lengths plus 2 widths, right? 2 lengths plus 2 widths. So I can multiply 2 times 4 and get 8, and 2 times 2.5 and get 5. So 8 plus 5 would give me 13. So the length of string that would go around would be 13 centimeters long. That's perimeter. Area you can think of as tiles, so square units. So there's 2 maybe tiles that go this way, and a little bit more, like 2.5 tiles. So if I were to add up all the tiles that would go across this shape, even including the half tiles, how many whole tiles would be covering the shape? And the way you can do that actually is, I have 2.5 groups of 4, so I could say 4 times 2.5, which would be 10. Or let's see, 2.5 plus 2.5 plus 2.5. So this is 5, and this is 5, so a total of 10. Or I could think of it this way: I have 4 plus 4 plus half of 4 is 2, so 8 plus 2 is also 10. So there's a couple different ways you can think about it. 2.5 times 4 is equal to 4 times 2.5. You can switch the order. So that's the number of tiles that would cover that space. So for a rectangle, we use the formula base times height. Okay, so that's for a rectangle. Perimeter is all shapes. So that's an easy one to remember. You just add up the sides. Okay, last thing is 3 dimensions. So 3 dimensions, I want you to think of cubes, right? They are, 3D, right? So 3D, if I want to find the volume of a shape, so this shape right here, how many cubes make up this shape? So if I count them by layers, so this top layer, I can find the area of this layer, right? 3 times 3, there's 9, or 3 plus 3 plus 3 is 9. So I have 9 cubes on the first layer, and then I'd have 9 cubes on the middle layer and 9 cubes on the bottom layer, so actually it's 9 times 3. So volume I would find just by multiplying the base times the height times the thickness, or whatever variables you want to give it. So these are just numbers, right? Length times width times height. So this is just different names for the same thing, right? I don't want to get you confused about variables. All they are is just numbers. So if it's 3 times 3 times 3, it'd be 3 times 3 is 9, and then 9 times 3 is 27, so there'd be 27 cubic units in this shape. Alright, let's talk about some more areas of different shapes. So there's also the triangle. Okay, a triangle, the way we can think about this is we know about rectangles, but we can't really cut this into squares. So what we can do is make it into a rectangle by just take that bottom base and I shift it straight up parallel, and then I just draw these lines in. Now it's a rectangle, right? I know the area of this rectangle. It's the base times the height. Well, how much of the area of that rectangle is taken up by the area of this triangle? Okay, so I don't. If somebody earlier on in your life has asked you this question, it's a good question to think about. Maybe you could pause the video and think about it yourself. How much of this area, if I took it as a percentage, for example, is it 30%? Is it 40%? Is it 50%? How much as a percentage does this triangle take up of that rectangle? Okay, I'll just go ahead and tell you. One thing you can do to prove it to yourself is, let's just draw a perpendicular line right there through the base. Now if I look at this rectangle, by symmetry I can tell you that the stuff over here is just as much as the stuff over here. So this is half of the stuff, right? Half of the stuff of that rectangle. And if I look at this rectangle over here, half of the stuff is there and half is missing. So this is also half of that rectangle. So if it's half of this rectangle and half of this rectangle, it's half of the whole rectangle. So 50% in other words. So 1/2 of the base times the height is what we use as the area of the triangle. Some people like to write it like base times height divided by 2. It's no different. It's the same quantity, same number of squares that would take up that space. You can do funny things with triangles like this. And how much area is in that? Well, all you do is the same thing. You can make a rectangle and just offset this parallel to the base, and then put a rectangle around it. Now, how much as a percentage? If you want to prove it to yourself, it's just this base now is what I'm concerned with, not the overall base. This is base, and we'll call this A. So the area of the rectangle I know is B plus A, right, times the height. And I want to take away, because I know that B plus A times H, 1/2 of it would be the area of this triangle, right? This triangle would be 1/2 B plus A times H. But then I want to take away this triangle, the white triangle in there. So that would be 1/2 A times H, right? So if I use the distributive property, I could multiply this out and get 1/2 BH plus 1/2 AH minus 1/2 AH. And actually, those two are exactly the same, right? 1/2 AH minus 1/2 AH. If I add something and take it away, that's just 0. So I get the same thing, 1/2 base times height. So no matter what your triangle is, you just take the length of the base and you multiply it by the height, or the perpendicular distance from the base to the other third point. Okay? Now, what about the perimeter of a triangle? Perimeter of a triangle, well, all shapes are the same. Whoa, I'm upside down. Rotate. Rotate. There we go. Okay, so that's the area of a triangle. The perimeter of a triangle, again, you just add up the sides, so whatever they are, length plus length plus length, and think of it as a string. Okay. Last shape I want to cover is a circle. Okay, a circle, if I take a string and I wrap it around the circle, how far around is that? Well, it happens to be the same on all circles, that if I measure across the center of the circle, and then I compare that length to the length around. So let's compare that length a little bit here. So it's about that long, and then I curve that around and I compare how many times does it go around? Do you think? What's your guess? I think it's about 3. Well, so if I compare how many diameters go into the circumference, that's the circumference. Actually, circumference is a new word, right? Circumference is just a fancy word for perimeter. Don't ask me why they decided to make up this word, but the circumference, that distance around, is the perimeter of a circle. And when you compare it to the diameter, it's 3 with a little bit more, and this number I have memorized out to a few digits anyway. 3.1415, actually 926. 926. There we go. This number approximately looks like that, but it's the number we call pi, and that's all it is. It's 3.1415 as an approximation. But that number pi happens to be the same on all circles, whether that circle is a little tiny dot or it's as big as the Earth. All circles happen to be the same, and they have that ratio of their circumference to their diameter. Now, the diameter is also defined as 2 radiuses, right? The distance from the center of the circle out, we call the radius. So if there's 2 radiuses stacked together, that's the same as a diameter. So you could write the circumference of a circle as switching the sides over here. If I multiplied both sides by the diameter, I get pi times the diameter. So you might see it as the circumference equals the pi times the diameter, or you might see it as 2 pi r. This is just 2 radiuses times pi. So it's these are the 2 ways that you would see the circumference of a circle written. Now, what about the area? So the area of a circle, you can't really cut this up into squares, right? If this was a radius of 3, I could cut it up into squares, but you see these little fractions of a circle would have a curved edge on them. So it's a little bit tricky to do it that way. One way that people have come up with the proof of the area of a circle is to split it up into pies, just like a pizza. So you split it up into more and more pizza pies. And then if we laid that out straight, so if we laid out a straight line and we unwrapped that string and laid it out straight, we'd have the circumference, which is 2 pi r. And then we had all these pies laying on that circumference. Now these start to look like triangles, but they have a little bit of error on the bottom there, see? And one of the things of higher mathematics called calculus is that you can break things up into smaller and smaller pieces until it's so tiny that it's virtually nothing. So we could break that up into smaller and smaller pieces, but it would still be missing a lot right here, right? So if I took half of these and I flipped them over on top of these, so then I would fill in all those gaps. So I took half of them off of here and put them over here. Now I fill in all these gaps, and I'd have kind of a parallelogram shape. It looks like this. And if I cut it up into more and more pieces, eventually this angle would be 0, and it would just be so many pies that it would make a rectangle, actually. And it would be a right angle right there, right? If I cut it up into an infinite number of pieces. So how big would this rectangle be? We know how to deal with rectangles, right? It's just the base times the height. So this distance right here, if I look back to my original circle, that distance was the radius, right? And this distance right here along the base, what did I do? I rolled it out, and this is 2 pi times the radius, and I took half of it and I flipped it over. So this is just half of 2 pi r, which is 2 divided by 2 is just 1, so it's 1 pi r. So I have pi r times r, which is just pi r times r is pi r squared. So that's where we get the area of the circle, and it's pi r squared.